In this video, we're going to be talking about something called the sampling distribution. Right, so kind of stepping back a little bit, recall the data analytics workflow. Right, so there's basically four steps. This is from the very beginning of the class. Basically, you start out by identifying the question and defining the population. So who or what are we studying? Who or what will we be able to make conclusions about? Then you take a sample and you have to ask questions like, is the sample representative? Does it accurately represent the population? And then we use this data to make conclusions. So something like, are two groups significantly different? What are the trends in this population? Basically using the data from that sample in order to make conclusions about the population. And then lastly, we want to evaluate our conclusions. How confident are we? What is our margin of error? And so far what we've done is kind of go through the steps of identifying the question, defining the population, talking about different types of data, looked at how to take samples, describing and visualizing the sample. And now we need to kind of move on to that third step, making conclusions. Right? So how do we do that? Let's look at a short example to kind of get us towards making the right conclusions. Right, so we're looking at a roulette game where basically we're placing a $1 bet on red 400 times. Right, so basically our question is, how much would we expect to win or lose? Right, so just kind of a quick primer on how roulette works. Basically, there's these 18 red spaces, 18 black spaces, and 2 green spaces. And so, assuming that each of these are equally likely, we win $1 if we get a ball landing on the red space. We lose $1 on any other outcome. Right. So this table shows kind of what the possibilities are. Right. So a roulette trial can be kind of thought of using this visualization, basically thinking of the probability of winning as maybe slightly below 50% because there's 18 red spaces and 20 non-red spaces. And then you have slightly higher than 50% chance of losing. Right. So this is just kind of what an individual trial probability might look like. Right, so what we're going to do is we're going to do this 400 times. Now in practice what we'll do is you will use simulations to do this automatically and repeat this many times. But basically what we're going to do is we're going to do this trial of 400 times betting on red, finding the overall winnings from those 400 bets, and then treating that as just one value, and then basically just kind of repeat this over and over many times. Right? So this is doing this many times, and basically this is our net gain on betting red, $1 400 times. Right? So you have basically centered pretty close to around -20. Basically you have this unimodal distribution. It's symmetric, and basically the range, the low end goes down to maybe -80, high end goes up to maybe about +40. Right. So basically, how did we get to this distribution? Well, this is, we're taking samples of size 400 from the population. The population is just all of the kind of roulette spins out, that are possible. And then we're taking samples of 400. So basically, we spin the roulette wheel 400 times, and then we get, we win $1 or we lose $1. And so we have those 400 samples that we get, and then that consists of kind of that one sample trial, and we get that overall value, overall winnings or loss from that one sample, and we do this many times. And so what we're getting is an aggregation of kind of these sample statistics, done many times. And so that's exactly what the sampling distribution is basically the distribution of the point estimates based on samples from a population. So if we were to take many samples from a population and we compute some sort of statistics. In this case, what we did was we looked at if we were to do 400 roulette bets, that overall sum of your winnings or losses. And so usually we observe just one observation from this distribution, right? So, usually, you're not going to go to the casino and do trials of 400 bets many, many times. You're going to just go once. You're going to do what you do, and then that'll be it. A better example might be, for example, if you just kind of do a survey. You get one sample from the population, you give them survey, and then you get the results of that survey, and that's all you really have. You have that one observation. Like from the survey, you might have the proportion of people who support a certain president, and so basically that'll give you that one statistic. Now, the sampling distribution is basically a distribution of that statistic if it were to happen many, many times. Right? So statistical inference is the act of making conclusions about the population and the reliability of statistical relationships using a sample from that population. Basically, we want to take that one sample that we have and we want to be able to generalize to that population. And so to do that, we're going to be using this idea behind this sampling distribution. And in general, we won't be able to actually go out and collect and get that sampling distribution. And so what we're going to do is we're going to kind of get at that theoretical sampling distribution using simulations. Right? So basically, we only get one value from that sampling distribution. Right? It's maybe a lot of times it's a mean, it's a proportion. In the roulette wheel example, it's a sum. You can also think of the sum as kind of like a mean. You just don't divide by the sample size. And so basically, we only observe that one value. And so how do we evaluate that within the context of a sampling distribution? Well, we use this theoretical sampling distribution based on simulations that we run based on a certain distribution. Right? And so this goes into something called the central limit theorem. Right? So basically we've been talking about this theoretical sampling distribution a lot, and the central limit theorem basically is what is going to give us that sampling distribution. Essentially what the central limit theorem says is given a certain conditions are met, then the distribution of a sample mean or sample proportion is going to be approximately normal. Now, we won't in this class need to kind of theoretically compute that, but we're going to be using simulations and we're going to be finding that sampling distribution. And the reason that it comes up as an approximately normal distribution is because of the central limit theorem.